Okay, number 21 is a coordinate proof. They give us that AKM is the triangle. It says determine whether the triangle is scalene, isosceles, or equilateral. So A is 4, -1. M is 5, 6. And K is 1, 3. So if I draw my points in, so now I'm just going to find the distances. So let's start with AM. Remember, I'm going to use the distance formula. The distance formula, we're going to do 5 minus 4 squared plus 6 minus a -1, so 6 plus 1 squared. So that's going to give us 1 squared, or 1, 7 squared, which is 49, which gives us the square root of 50, which if I put the square root of 50 into my calculator, I do the second function, 50, that gives me 7. Now I'm going to round this to the nearest tenth, 7.1. So AM, the length is 7.1. Now, I'm also going to find the length of AK. So AK, again, use the distance formula one more time. So I'm going to do 1 minus 4 squared plus 3 minus a -1, so that's 3 plus 1 squared. So that gives me -3 squared, or 9. 4 squared is 16, so that gives me the square root of 25, which the square root of 25 we know is 5. I then have to find the length of one more side, so I have to find the length of Km. So Km, I do the square root. Km is going to be 1 minus 5 squared plus 3 minus 6 squared. 1 minus 5 squared is 16. 3 minus 6 was going to be -3 squared, which is 9, which also gives me the square root of 25, which is also 5. So as I look at my 3 lengths, or 3 sides here, notice that 2 of them are the same. So that would say, because 2 of the side lengths are the same, this would be an isosceles triangle. Okay, let's take a look at the proofs here on 22 and 23. So in 22, again, you're given. They tell us that Q is the midpoint of PR, and they tell us that angle T is congruent to angle S. So if Q is the midpoint of PR, I can say that PQ and QR are congruent. That's the definition of a midpoint. They tell us that T is congruent to S, so I'm going to mark that in my picture. I'm going to put a number in here, a couple numbers, so 1 and 2. So I'm going to say angle 1 is congruent to angle 2. That's vertical angles congruent. And if we mark that in the picture, notice that we have now angle, angle, side to prove the triangle is congruent. So I can say triangle TPQ is congruent to triangle SRQ by angle, angle, side. Okay, this number 23, they tell us that AD is congruent to CB, and CB is parallel to AD. That's our given. I'm going to go ahead and mark AD and CB. Now, because CB and AD are also parallel, we can think of this as being our transversal. So I could now state that angle 1 is congruent to angle 2. because if lines are parallel, alternate interior angles are congruent. So I'm going to mark 1 and mark 2. Now, probably the easiest thing to do now is to just say simply that BD is congruent to BD because the two triangles share that side, so that's reflexive. And you can see now in my picture, I can now prove the two triangles, triangle ADB congruent to triangle CBD by side angle side. Okay, our last proof here on this one, they're actually giving you some of the information already filled in. So telling you that AT is congruent to PM, that's already marked. PM and AT are parallel, that's already marked. They're telling us that ATM, angle ATM and PMT are congruent. So ATM, that's this angle, and PMT, that's this angle. They're telling us that TM is congruent to TM. That's going to be the reflexive property. They're then saying that triangle PMT is congruent to triangle ATM. Well, notice now we can say that by side angle side. And then they want us to show that angle PTM and AMT, which is this angle here, PTM and AMT is congruent to this angle. And we can say that. This is called CP/CTC. This is not something that's going to be on your test, but we call that corresponding parts of congruent triangles congruent. So because the two triangles are congruent, basically the corresponding parts are congruent. That's what CP/CTC stands for. And again, that is not going to be on your test, but is something that we utilize in our next steps as we look at proving parts of a triangle congruent.